Hi everyone. Our learning target for today is I will solve for speed of an object using distance and time. And I will quickly go through our slides from class today. I'm going to show you how you calculate for speed using distance and time. One quick note, make sure that your Unit 2A notebooks have been turned in. Okay, they are late at this point, so please make sure that we get those turned in. Don't want anyone having missing work. Okay, so a quick warm-up that we did in class. We had discussed units of measurement last week. So which of the following describes distance? Is it 36 miles, 36 hours, or 36 miles per hour? So hopefully in your head you chose 36 miles because yes, that is distance. Okay, 36 hours is time. And 36 miles per hour with distance over time is speed. Okay, and that's important to know as we move into calculating distance, speed, and time. Okay, so as you're watching this video, please make sure that we're paying attention and then that we think about the answers to the questions of how do you calculate speed, how do you know how fast something is going, and what two components do you need in order to calculate speed.
This question is all about distance, speed and time. I'm sure you will have learned about it at school, but here's a quick refresher in case you've forgotten. So, the first thing you need to do is draw a triangle like this one. You need to populate the letters in alphabetical order. So, D at the top, S to the left, and T to the right. In this example, we've got a train that travels 1,250 kilometres in 3 hours, and we need to work out what the average speed is. So, by referring to your triangle, if you cover over the S, which is what you want to work out, you can see that you have D over T. So populate this with the values that you have, so 1,250 over 3. 1,250 divided by 3 is 417 kilometres per hour. Now this triangle will work if you're trying to find out the distance, so distance would be speed times time, or if you're trying to work out the time, then that's distance divided by speed.
Okay, so we need distance and time in order to calculate speed, okay? So I'm going to show you how to work through this problem, okay? So Tina's calculations of the tarantula found that the spider was able to cover 20 centimeters in 5 seconds. What was the average speed of the spider? Okay, so what I'm going to do is I'm actually going to pull up this little example here. I'm going to change the color. Okay, so what I'd like for you to do each time that you're working through one of these problems is you're like, oh look, there's centimeters. Okay, that's distance, right? Okay, not a good looking D there, but you know, you get the idea. Okay, then we have 5 seconds, so that's time. Okay, so what was your average speed? It's wanting to know the speed, right? Okay, so for distance, we've already figured it out. That's 20 centimeters, okay? And always make sure that you put the unit of measurement as well, even if it's painstakingly hard to do on a mouse pad, okay? The time is 5 seconds. Okay, and what work means is I'd like for you to show your work. Okay, so we're trying to figure out speed. So speed equals distance over time, right? So 20 centimeters over 5 seconds, okay? And what is that? Well, you'll need a calculator sometimes. But this one, the speed equals 4, but not just 4, okay? It'll be 4 centimeters per second, okay? And this problem is actually in your notebook, which is what you are going to be working on and need to have completed by this weekend, okay? If you have any other questions, please let me know. Please shoot me an email or a remind message, and I'd be happy to help you, okay? So, for Monday and Tuesday's classes of A and B, you will need to work on slides 2 through 8. Okay, thank you.